So we've already talked about two types of transformations. Translations and reflections. So now we're going to talk stretches. And you were asked to make these graphs. The first one you were asked to do y equals x squared, which is the red one on both of these graphs, y equals x squared. And then y equals 2x. And the other one, was it y equals 1/2 x? Yep, y equals 1/2 x. So this blue one on the left is y equals 2x. The blue one on the right is y equals 1/2 x. And those are the first three graphs that you were doing. And what you should notice about it is, first of all, the graph of y equals a times f of x is not congruent to the graph of y equals f of x. So it's not the same size and shape anymore. It's the same general shape. It's still a parabola, but it's narrower or wider. It's actually taller or shorter, but because they're all infinitely wide and infinitely tall, it's kind of a strange definition of taller. But I say taller because it has been stretched up for y equals 2x. And for y equals 1/2 x, x squared, those should be squareds, it's been squished down. So it makes it look wider. If you think of taking something and squishing it down, it gets pushed out to the sides as you squish it down. Or if you pull it up, it kind of gets skinnier. So it looks like this graph is, the first one is narrower and the second one is wider, but really the first one is taller and the second one is shorter. So it's been stretched up and squished down. So what are we going to put in here? The graph of y equals a times f of x is not congruent to the graph of f of x. It is stretched vertically by a factor of a. It's stretched vertically by a factor of a. So if a is 2, it's stretched to 2 times its vertical size. If a is 1/2, it's stretched to half its vertical size. Do we have invariant points? The invariant points lie on the x-axis. Did anybody come up with a mapping rule?
X, y goes to x, and then y times the a value.
Right. So xy maps to x and ay. X stays the same, the y value is multiplied by a. Given the function y equals f of x below, so this is actually the same function we were looking at yesterday. It's a piecewise function. Sketch the graph of y equals 1/3 f of x. So just like yesterday, we're going to write a mapping rule. X, y maps to, we said it's x and ay, so it's just x and 1/3 y. This is when the stretch factor, which is what that 1/3 is in front of the whole function, right? In front of the f of x. These are some key points on the original function, and then if we transform them, all the x values it says are going to stay the same. So this is still going to be -5. This is still going to be -3. This will still be 0, 3, and 5. The y values, we multiply them all by 1/3. So the 2 will transform to 2/3. The 0 will stay as 0 because you multiply by 1/3, it's still 0. The 3 will change to 1. The -3 to -1, and the -2 to -2/3. And then if I plot those points, that'll give me the transformed function. So -5 and 2/3 is around there. -3 and 0, there's one invariant point. 0 and 1, 3 and negative 1, and 5 and negative 2/3. Do you see the two invariant points? There and there. That's one, and that's the other, the x-intercepts. And I like this one because you can really see that it looks like the same graph, but squished down to 1/3 its height. Because it actually doesn't have infinite height, you can actually see that it's 1/3 of the size that it originally was. Squished down to 1/3 its size. Then we had these ones where you were graphing y equals x squared. But then you also did, I think, let me check, I think that's y equals 3. Y equals 3x squared and y equals 1/2 x squared. And you can see by the way that they're written that these are different than the ones that we just did. The stretch factor, the 3 and the 1/2 here are inside the brackets with the x, not on the outside like they were before. So this is not a vertical stretch. This is a horizontal stretch. So the graph of y equals f of bx is not congruent to the graph of y equals f of x. It is stretched horizontally. What's the stretch factor here for y equals 3x squared? Yeah, it's squished into 1/3 its horizontal size. So it's not, 3 is not the stretch factor, 1/3 is. And in this one with the 1/2, it's stretched out to twice its horizontal size. And so the stretch factor is not 1/2, it's 2. So what that means here, it is stretched horizontally by a factor of 1/b. It's the reciprocal of the number that's there. That's the stretch factor. Invariant points we already talked about. Where are they going to be? On the y-axis. And the mapping rule will be xy maps to 1/b times x and y. And that takes us to this, where given the graph of y equals f of x, sketch a graph of y equals 2f of 3x. So this actually has two transformations happening. Can you describe what those transformations are?
Vertical stretch by a factor of 2.
A vertical stretch by a factor of 2, yes. And a horizontal stretch by a factor of 1/3. Those are the two transformations that are happening. So then we're going to make a mapping rule. xy maps to. What's it going to be? 1/3 x and 2y. That's how we put both of them in a mapping rule together. So I'm going to change all of the x values first by multiplying them by 1/3. So this is going to be negative 5/3, negative 1, 0, 1, and 5/3. And then I'll multiply all the y values by 2, so that's 4, 0, 6, negative 6, and negative 4. And then those are the points that I'm going to plot. Negative 5/3 and 4. That should be around there, right? Negative 1 and 0. 0 and 6. Uh-oh, that's up there. start joining those together. And then 1 and -6, way down there. That's going to be difficult for me to draw. Oh, I didn't do too bad. And 5/3 and -4. So there's the transformed function. Stretched vertically by a factor of 2, so it's twice as tall, but 1/3 as wide. Stretched horizontally by a factor of 1/3.